are in the second now lecture of sedimentary rocks. Sed rocks number 2. And we actually quit in the middle of a list, which was the 4 different types of sedimentary rocks. And we went over chemical, biochemical, and organic. And what I'd like you to be able to do is remember the things like coal and travertine, halite, limestone, chert. I'd like you to be able to interpret, so from last time, let's say, from last time, when you see these in the sedimentary record, you would like to be able to interpret the history of our planet and understand the environment that they came from. So the interpretation that you'd be worried about when you see those others is environment. So a geologist would want to say, oh, I see a coal deposit. Well, that tells me we used to be in a swamp. That's the kind of connection I want you to be able to do with these sedimentary rocks. Now, this is chapter 5.3 in that online textbook. And now we're going to get into number 4. This is clastic sedimentary rocks. Clastic rocks. This represents about 75% of all sedimentary rocks on Earth's surface. And I want to break it down for you in a terminology way. Clastic is based on the word clast, and clast means particle, right? Which you could think of as sediment. Some people teach clastic rocks with a different name, and they call them detrital rocks, and that is based on the word detritus, which means like broken up garbage, which again gets you to sediment. All right, so these are like the clastic sedimentary rocks. The process by which we get clastic sedimentary rocks deposited is we're going to have weathering of some previous rock, right? We could call that the parent. Weathering of previous. And then there is transport that occurs that's going to be moving those sediments somewhere. Eventually, deposition will occur when the carrying capacity of that fluid can no longer keep that particle in motion. And then we get lithification. Lithification is the rock turning process. So as I put those words down as the recipe for getting a clastic sedimentary rock, I hope you're making a connection to sediments and the word provenance. All right, that has to do with the parent, where things are coming from. Transport, this is a filter, and it's going to filter by energy. It's also going to do something that it's going to abrade, right? This is how particle shapes are produced. Deposition has to do with carrying capacity and energy. And then lithification we need to break down into its own thing. So let's go here. Lithification means taking sediments and turning them into rocks. Lithification, there's 2 steps in order to lithify sediments. We need to do 2 things. So it's lithification by compaction plus cementation. And we'll draw 2 little sketches for this, but compaction, this is going to be burial. And as we bury something, there's more compression and there's a removal of porosity. So we can say like porosity decreases. And we could imagine a box that's this big, and then after this period of burial and compression, the box is now this big. The particles have been pressed much, much closely together and the porosity has been diminished. The other process for lithification is cementation. This means cement. And so what we could say here is that like minerals precipitate in pore space from groundwater. There's groundwater basically everywhere in the subsurface, and a lot of times there's material inside of that water that wants to make crystals, and so some of that'll precipitate out and make a natural cement. So if here we had a bunch of sand grains that were loosely held together and maybe a water flowed through there, it could then later precipitate a mineral in this pore space, and it would actually do it in such a way that it would make these beautiful, sometimes it actually makes like these beautiful crystals that are interlocking, that are holding that rock together. All right, so as I go through this list now of the types of clastic sedimentary rocks, this is what I want you to be thinking about. transportation and provenance, deposition, lithification by compaction, and cementation. There's not as many photographs today, but I'll show you some of the actual rocks that we go through. I think we could do this in somewhat of a table and a list. We're going to go like the name of the rock, then we're going to go the size of the sediment, because this is how this is. Let's put this classification table. We have a clastic sedimentary rock put in front of us and we don't know what it is. Well, we could go to this table to help figure out. And we're going to go, okay, so here's the eventual name, the size of the particles, the sorting of the particles, the rounding of the particles is important. And then finally, we can talk about the interpretation of how do we get that combination of rounding, sorting, size to get this material. All right, so the first rock type is a Breccia. The second rock type is a conglomerate. I'm going to group these two together because they're similar in many different ways. They both are large sizes. I'm actually going to put the word all. For what size of sediment occurs in a Breccia and a conglomerate? Generally all do, because they're very poorly sorted. But the size that sticks out the most to your eye is not the small things. Your eye can ignore those. But what you tend to see is the things that are greater than pebbles. So I'm going to go greater. Oh boy, how do we do this in a neat way? The size is bigger than pebbles is what will stick out to your eyeball. Greater than pebbles. Even though there will be clay-sized particles and silt size as well, these have large granules. The difference between Breccia and conglomerate has to do with their rounding. Breccias have angular fragments and conglomerates have rounded conglomerates. The interpretation for Breccia and conglomerate are largely similar because the sorting is similar and the size is similar. Rounding is the one difference, and that also shows up in the interpretation. They are both high energy. So this means like fast moving water, fast moving rivers, like waves with big, or beaches with big waves. But then Breccias have short transport. We'll say short travel, and conglomerates have, let's say, medium travel. Short travel does not bang the corners off, whereas a conglomerate has more rounded edges because they've been chipped away. Our picture here, let's take a look at these two pictures. Can you tell which is a Breccia and which is a conglomerate? The thing that'll give it away is our rounding. This, look here, look at these grains. These are rounded grains, and so this side is our conglomerate, and this side, if we look at the grains, it's very poorly sorted, very fine grain, bigger chunks in that matrix. This is angular, and so this is our Breccia. All right, let's keep going down through this list. We're getting in now into the realm of sandstones. We'll put the picture in first for sandstones. All right, here's our sandstones. The grain size now becomes smaller so that it's harder to see, but I'm showing you two different sandstones in this picture. I'll explain them in just a second, but this one is quartz dominated. Quartz is really stable and survives actually we use the word mature. A quartz sandstone is very mature, and sandstones with more feldspar minerals or rock fragments are more immature. It has traveled less. Traveled more. Traveled with two L's and traveled with one L. It's a good thing I'm not a spelling professor. Okay, so we're gonna say let's go ahead and put lithics, and we're gonna put feldspar. These are the indications, and in the table below I actually just use the word mixed, but when I say mixed, I'm talking about lithics and feldspar, telling us that it is less transport. All right, so back to our table. In here we got the sandstone is our name, and our size for sandstone is going to be sand primarily, or less than sand. The sorting for a sandstone we could say is medium to good. Sometimes your sand will be incredibly well sorted, and other times there'll be silts mixed in, so it can have a range of sortings. Our rounding, all are possible. You can have angular sandstones to rounded sandstones, and then in our interpretations, when it's quartz dominated, versus mixed, we're going to have slightly different interpretations. All right, for quartz dominated, it is long transport, medium energy. Medium energy. And for a mixed, if there's lithics and feldspar still present, then it is medium transport and medium energy. Medium energy means a flowing river or a beach with medium-sized waves. You know where sand forms. All right, under sand, it's going to be our next rock is a siltstone. And then we have mudstones and shales to finish off. So mudstone and shale. And as we walk through these three, they are all very fine grained. You can't actually see the grains with your naked eye, and the way to tell them apart is by crunching them between your teeth and seeing if it feels gritty or if it feels smooth. So the particle size for siltstone tends to be silt size, and for mudstones and shales, these are the finest of all particles, and they are clay sized. The sorting is good because the particles are so small, they're not mixed with anything bigger. And the angularity, I'm just going to leave these blank. We can't even see, unless we have some really powerful microscope, we're not going to be able to see the rounding, and so it's not going to be informative of anything. The one difference that I do want to speak to differentiate these, besides the particle size, you notice mudstones and shales have the same particle size, the same sorting. They're really hard to tell apart until you look at them, because a mudstone doesn't have any structure or layering. So we're going to say no layers. Whereas a shale forms sheets and beds that make it more recognizable. So let's go over to our environment interpretation. For a siltstone, the interpretation here is that this is a low energy depositional environment, and for mudstones and shales, these are very low energy environments. These are things like lakes or deltas where the water and wind, or I guess a desert with low winds, aren't able to carry these particles very far. I do have one picture here to finish off. Let's get a picture of a shale. All right, so here's our picture of a shale here on the left. It's a black shale full of rich carbon. Maybe it's even a source rock for oil. But what you can see is that there is this, in fact, the technical term for this is facility. But facility are the layers that we're seeing, and the rock tends to break off in these flat fragments. How do you spell facility? I don't know. It's F-I-S-S-I-L. Fissile. And then this rock here over on the side, this is technically a siltstone, but it also could be a mudstone. We can't tell. We don't see any internal layering. So the only way to tell if there's a siltstone or a mudstone would be to see its grittiness level.